Okay, so now let's look at matrix multiplication. We would like to multiply two matrices together. In order to do this, we're going to do the dot product for the row and the column that the entries are coming from. So if I'm looking for the row 1, column 2 entry of the product, then I would do the row 1, column 2 dot product of the row from matrix A and the column from matrix B. Now, just like before, the dimensions must match up accordingly. So if I have an n by m matrix, then the matrix that I'm multiplying it by must have m rows, and it could have some other number of columns. But these inner dimensions must always match. If they don't match, then you can't do the matrix multiplication. So let's take a look at this example here. We would like to multiply these two matrices together. So for the row 1, column 1 entry of our matrix, we're going to need to do the dot product of row 1, column 1 in order to row 1, column 1 in order to multiply these two matrices together. Before we get too far ahead of ourselves, let's just make sure that this multiplication is valid. So our first matrix is a 2 by 2 matrix, and the second matrix is a 2 by 3 matrix. So the inner dimensions match, so that's good. Also, we can say one more thing. The product will be of size 2 by 3. The rows from the first and the columns from the second. So this will give us a 2 by 3 matrix. So that's something to keep in mind. We'll check at the end that we got a 2 by 3 matrix. Okay, so first let's do this dot product to get the row 1, column 1 entry. Now remember, the dot product says I take the first entry in the row and the first entry in the column, and we multiply, so we get 1 times 0 plus the next entry in the row and the next entry in the column. So plus 5 times 3. This will be my row 1, column 1 entry for this product matrix. Okay, so now let's try to get row 1, column 2. So let's go ahead and erase all this. We're looking for row 1, column 2. So now we're doing the dot product along row 1 and column 2. So again, our first entry would be row 1 first position, column 2 first position. So we have 1 times -1 plus, and then we move on to the second. So we have 5 times -2. 5 times -2. And that would be our entry for row 1, column 2. Let's do the same thing for row 1, column 3. Row 1, column 3. Okay, so our first two entries being multiplied together are the first entries for the row and the column. So we have 1 times -3 plus 5 times 4. 5 times 4. And that would give us the row 1, column 3 entry. So we follow this same pattern in order to get the other entries in the second row. Except for the second row, we will be doing the dot product of row 2 with column 1, and then column 2 and column 3. So the dot product of row 1 with column 1, row 2 with column 1, we will have 3 times 0 plus 2 times 3. If we move on to the next column, so now we're looking at row 2, column 2, we will have 3 times -1 plus 2 times -2. And finally, if we look at the third column, still the dot product with the second row, we end up with 3 times -3 and 2 times 4. So we're doing the dot product at each piece along the way. So now let's go ahead and figure out what these values actually are. 1 times 0 is 0, plus 5 times 3, we get 15. Let's see, the next one in that column would be 6, and then moving on to the next column after that, we get negative 11, negative 7, 17, and negative 1. And so this 2 by 3 matrix is the product of our original two matrices. And notice that we did end up with a 2 by 3 matrix, just like we said we should in the beginning. Okay. The hardest thing with multiplication is just making sure that you keep the rows and the columns in the correct place. So a couple things to sort of notice that you can double check to make sure you've done your multiplication correctly. Anything from the first row will always have the entries from the first row of the first matrix. So those should all have a 1 and a 5 in there. And the second row should all have the entries from the second row. So the second row, they all have the 3 and the 2 in this example. So sometimes those get switched around, so that's something you can check. Make sure that all of your entries have the same coefficients. Similarly, the same thing is true with the columns. So notice in the column 1 was 0, 3, and so in the first column, each term has 0 and 3. But that doesn't happen, there are no 0s and 3s in column 2 and column 3. Column 2 was negative 1, negative 2, and each entry has a negative 1, negative 2 if you're in column 2. And the same thing holds for column 3. We get a negative 3 and a 4. So you can sort of double check that your calculation is correct. Alright,